Alright, in this video we're going to talk about applications and modeling using quadratic equations. So this is just going to kind of apply some of the stuff we've already learned, some of the methods we've learned about solving quadratic equations. The first application we're going to talk about is from geometry and trigonometry, the Pythagorean theorem. If you're given a right triangle, that means a triangle that has a right angle, a 190-degree angle. You have two short sides and a long side. The two short sides that make up the right angle are called the legs of the right triangle, and the longest side across from the right angle is called the hypotenuse. And Pythagorean theorem says that in any right triangle, the sum of the squares of the legs is equal to the square of the hypotenuse. So if I square the length of leg A plus the square of leg B, you get the square of the hypotenuse. So A squared plus B squared equals C squared is the Pythagorean theorem. So let's do a problem where we use this theorem. Use the Pythagorean theorem to find side A if side B equals 12 and side C equals 15. So in this problem, we're not given A, so that's going to be our unknown. And then we have B squared equal to C squared. So A squared is just going to remain like it is. B, however, was 12, so that's given information, so 12 squared. And side C was given also, and it's 15, so 15 squared. So to work this problem out, we're going to work out the arithmetic here. So you have A squared plus 12 squared is 144 equal to 15 squared, which is 225. So I'm going to solve this now quadratic equation by subtracting the 144 from both sides. It's quadratic because you have a squared term. So A squared equals 225 minus 144, which comes out to be 81. Now we know to solve for side A, then we're going to have to take the square root. So the square root property, I can take the square root of both sides. So we get A equal to, normally we would put plus or minus here. But since this is a geometry application and we're finding the length of a side, a length cannot be a negative number. So we're just going to use the positive square root. The square root of 81 is 9. So if B is 12 and C is 15, A would equal 9. This is an application of a quadratic equation. Here's more. This is going to also involve the Pythagorean theorem, but a more applied type problem. It says a boat is being pulled into a dock with a rope attached to the boat at water level. When the boat is 12 feet from the dock, the length of the rope from the boat to the dock is 3 feet longer than twice the height of the dock above the water. So find the height of the dock. So let's draw a picture here so we kind of get an idea of what we're looking at. Here's my dock. The water's down here. And we know we have a boat out here on the water somewhere. Okay, it says that a boat is being pulled into the dock with a rope attached to the boat at water level. So it's attached to the boat at water level. So we're going to say the rope, here's the dock. We're going to say that's the rope. And we're going to say that that's pulled tight there. Okay? When the boat is 12 feet from the dock, so the distance of the boat from the dock is going to be the distance horizontally here. So it's 12. So we'll say that that's the distance from the boat to the dock. We label that this is the dock. Okay? The length of the rope from the boat to the dock is 3 feet longer than twice the height of the dock above the water. Well, we have no idea how tall the dock is above the water, so we're going to call that our x value, or unknown. But we can interpret the length of the rope now that we know that the height above the water is x. So it says it's 3 feet longer than twice the height. So twice the height would be 2x. 3 feet longer would just mean we're going to add 3 to it. So there we have are three sides to an example of a right triangle situation here. So the legs are x and 12. The hypotenuse length is 2x plus 3. So that's how we'll set up our equation. So x squared plus 12 squared will equal the hypotenuse, which in this case is 2x plus 3 squared. So now we'll just have to work out the algebra on the problem. So you have x squared plus 12 squared will be 144 equal to, on the right side we have a binomial squared, so you could write that down twice and do the FOIL method, or you could square double square like we learned in earlier algebra courses. You square the first term, so 2x times 2x makes 4x squared. Multiply the terms together and double it, so 2x times 3 would be 6x, but if I double that it would be 12x. And then square the last number, 3 squared would be 9. Some of you may remember that method from earlier algebra classes. If you don't, then you could of course write 2x plus 3 times 2x plus 3 and then use the FOIL method to multiply that out. So I'm going to move some stuff over here. I'm going to move my x squared over to the other side and also the 144. We're going to move that over as well. So I'm going to have 0 equal to 3x squared plus 12x, and then 9 minus 144. So negative 135. So one thing I want to check right off is to see, will 3 divide out of this equation? Because we have this 3x squared, I'm thinking if we could reduce this equation, that'd be nice. And actually 3 does divide into 135. So let's divide the whole equation by 3. So that's x squared plus 4x minus 135 divided by 3 is 45. Okay, so this is a factorable equation. We don't have to use the quadratic formula. We can factor. So in this case, two numbers that multiply to give me negative 45, add to give me 4, would be positive 9 and negative 5. So if I find the solutions to those two equations, x would equal negative 9 and positive 5. Now, since we're talking about length here, length cannot be negative, so we're going to just disregard that negative answer we got there. So we're going to use x equal to 5 to answer the question that's being asked. Find the height of the dock. Well, actually, that's what we were looking for, x. So in this case, x would equal 5 feet. Now, if the question had asked us, like, how long is the rope, then you would use the 5. You would actually say 2 times 5 is 10, plus 3 and got 13. But in this case, 5 is what we were needing. So another application of the Pythagorean theorem. Here is another type of application we might see when we're talking about quadratic equations. This one involves area. Zachary wants to buy a rug for a room that is 12 feet wide and 15 feet long. Those are the dimensions of the room. So we're going to have a rectangular room, it looks like. And we're saying that the room is 12 feet wide and 15 feet long, so 15 by 12. He wants to leave a uniform strip of floor around the rug. So he's going to put a rug in this room, but he wants a uniform strip of floor around the rug. So we're going to put the rug in. But he wants the space around it to be uniform. In other words, he wants it to be the same width all the way around. He can afford to buy 108 square feet of carpeting. What dimensions should the rug have? So what we need to know, since it's uniform, we need to see that this distance we're going to cut off is the same as this, and throughout the entire problem. So how much space we're going to leave, we're going to call that our unknown. How about x for those values, because we don't know how much that's going to be. So the dimensions of my rug, according to the picture that I've drawn here, the length of the rug could be 15. But if I take off x from both ends, that's going to take away 2x of length away from that. So the rug would be 15 minus 2x's across. So the length would be 15 minus 2x. Now the width should be like the same thing. The width of the original rectangle is 12, but if we take off x from top and bottom, that would be 12 minus 2x. But we know that the area of that rug can only be 108 square feet. So here's my equation that I want to try to solve here. So let's remultiply here on the left side. We're going to multiply this out using the FOIL method. 15 times 12, we'd say is 180. Outer would be negative 30x. Inner would be minus 24x. And then negative 2x times negative 2x would be plus 4x squared. And that's equal to 108. Now I can subtract the 108 from both sides, so that's going to leave me 72 minus 54x plus 4x squared equal to 0. Now that's not in descending order, but we can rewrite it where it is. And 72, 54, and 4, maybe I could divide a 4 out. 72 is divisible by 4. 54, however, is not divisible by 4. So the most I could divide out of this equation to reduce it is a 2. So I'm going to divide out 2, so that would give me 2x squared minus 27x plus 36. So let's see. Maybe I can factor this equation. We're going to try to. The 2x squared I could factor as 2x times x. And then the 36, we've got lots of different choices we could use here. We could use 6 times 6. We could use 4 times 9. We could use 3 times 12. And in this case, actually, 3 and 12 are what works. I couldn't put 12 with the 2 because they would have a common factor. So I think this is correct. Let's see. Outer product would be 24x. Inner product would be 3. 24 plus 3 does make 27. So these both need to be negatives here. So if we set our factors equal to 0 now, we get 2x minus 3 equal to 0. So let's see, if I add the 3 and divide by the 2, add 3 to both sides and then divide by 2, x would equal 3 halves. And then x minus 12, if I set that equal to 0, I get x equal to 12. Now we have a problem with one of these answers. One of them would not be able to work. In fact, for x, this little bitty amount right here could not ever be 12 because the whole length itself is 12. So you couldn't take 12 away twice from 12. So we're going to go ahead and disregard that value. So x must be 3 halves. So let's think about the dimensions of our rug. The dimensions of our rug were given previously in the problem. 15 minus 2 times x. So let's see what that would be. 15 minus 2 times 3 halves. And then the other dimension was 12 minus 2 times 3 halves. So let's see. That would give me 15 minus 3, which is 12. And this one would give me 12 minus 3, which is 9. So 9 by 12 would be the dimensions that I could possibly use of the rug. And if you think about that, 12 times 9 is 108. So the area would work. Let's do one more example that involves quadratic equations. And this one comes from physics. A projectile is launched from ground level with an initial velocity of 96 feet per second. Neglecting air resistance, its height in feet t seconds after launch is given by this function. S is equal to negative 16t squared plus 96t. We call this the position function in calculus class. Find the time, or the times the projectile will reach a height of 80 feet. So since this is the position function, we want to know when this is equal to 80. So my equation will actually be negative 16t squared plus 96t equal to 80. Now, of course, I need to move the 80 over to the left side. So I'm going to go ahead and subtract my 80. We also don't like a negative coefficient if we can keep from having that. Let's see if my numbers are divisible by 16. 96 divided by 16 does work, and 80 divided by 16 also is divisible. So we can divide by negative 16. So t squared minus 6t plus 5. That's dividing through by negative 16. So in this case, I believe this equation will factor two numbers that multiply to give me positive 5 but add to give me negative 6. That would be negative 5 and negative 1. So at t equals 1, at 1 second you're at 80 feet, and at 5 seconds you're at 80 feet. And 5. Well, that's not writing too good. Let's see here. Okay, how in the world could it be at two different times? Well, it's a projectile launch, so we could say that here's 80, here's the model of the picture, and at 80 it could be here on the ascent up, and then 80 also here on the descent down. So it could be 80 at both of those places. So after it's been in travel for 1 second and after it's been in travel for 5 seconds. And notice in your problem